Well, I think I can go ahead and get started. I think a lot more people will be joining, but they're not here for my introduction. So I'll just go ahead and start. So we have a very exciting speaker here today, Artem Trotsyuk, who is currently a fellow at the Center for Bioethics at Stanford. So I'll introduce him fully in a second. But first, we usually give a brief introduction to the AI Precision Health Institute and our monthly affinity group meeting. So this is a monthly meeting where we come together to hear from leaders in the field, such as Artem, to discuss trends in AI for healthcare. Now, we usually bring a diverse array of speakers from a variety of different research fields, together with clinicians and advocates, in order to foster collaborative introductions to solve problems in cancer and healthcare that were thought to be unsolvable a decade ago, but now with AI is becoming much more feasible. So the format of these talks is a roughly 30 to 40-minute presentation, followed by an interactive question and answer period / discussion. And we should not be shy about engaging our speaker as usual. Our speakers usually very much appreciate that to get a lot of questions. We have an exciting lineup of upcoming speakers from various fields applying AI to various healthcare tasks. If you have any feedback or suggested speakers, don't feel shy about sending those over to John Shepard and myself. We are hosted at the intersection of a few institutions within UH. One of those is the UH Cancer Center. The other is the Artificial Intelligence Precision Health Institute within the Shepard Research Lab in the Cancer Center, as well as the Hawaii Data Science Institute. A tradition that we have is to describe a paper of the month. This month's paper is written by our speaker today, who will likely discuss some of the topics described in this paper, published in Science Translational Medicine, one of the top journals in AI for healthcare. So if you're interested in the content of this talk and would like additional information, definitely check out this paper. We also, Artem, have speaker compensation in the form of a beer stein, which Amy might have contacted you about, but you will be receiving that in the mail, branded with the Artificial Intelligence Precision Health Institute logo from the University of Hawaii. So we hope to receive a picture of you and the beer stein. So without further ado,
I love it.
good to have fun, you know. So without further ado, I'd like to introduce our speaker. So Dr. Artem Trotsyuk is an AI ethics and policy fellow within the Stanford Center for Biomedical Ethics, where he focuses on evaluating unintended consequences of AI in biomedicine and then developing frameworks to address these issues. Prior to that, Artem completed a PhD in bioengineering and a master's in computer science at Stanford, where he worked on AI-powered closed-loop smart bandages. So without further ado, Artem, why don't you share your screen and take it away?
Sounds good. Give me a second. Continue. All right. Let's do this here. Let's do slideshow. Okay, I think I need to do a new share. Give me a sec. Stop share. There we go. Okay. I think you should be able to see the slides. Okay.
Yeah, we can see.
I'll chat. See if I have any questions. Okay. So before I start, I'd love to kind of get a sense of who is in the room. So as a way of engaging my audience, do you mind raising your hand or using the raise hand function if you use AI on a weekly basis in your work, raise your hand, please. So I can get a good idea. Okay, so getting a lot of hands raised. Okay. Amazing. So about half of the folks are attending. That's a little bit more than half. Okay. It's helpful for me to understand that because then I can kind of frame this talk and help you um, learn a little bit more about what I've been working on since doing a very technical PhD program. So with that, I'm just going to go ahead and jump in. The title of my talk is going to be focusing on mitigating unintended consequences of AI in biomedicine. So, oops, let's see, there we go. So a little bit about myself, as Peter had mentioned, I did my undergraduate training at UC Davis. I studied biology. I then pursued a master's in computer science with an emphasis in pure AI models at Stanford, and then did my PhD in biomedical engineering at Stanford. The PhD focus was very heavy on the technical development work of using smart devices for capturing data in the form of sensor integration, sensor data from wounds, and using that data as a means to predict the outcome of a wound and how quickly it can heal, given things like pH, impedance, temperature, and other factors that we used and collected from patients at the Stanford Advanced Wound Care Center. The focus here was to see if you can use big data as a means to translate some sort of more actionable and clinically relevant type of outcome in order to help patients be able to have better quality of care, particularly with patients who have chronic wounds that are not healing, the diabetic patients and folks who are struggling with just wound reoccurrence. And in doing so, we're able to model the progression of the wound and create a spatial wound healing map, and where you can use sensors that can predict to predict incoming or wounds that are about to get gnarly or about to get infected by using temperature and impedance. We ran a few algorithms, different types of regression analyses to figure out what are the most important sensors. And we found that both impedance and temperature were the most relevant and most interesting sensors, data points that would be able to predict with a roughly 85% accuracy how well your wound will proceed in both the direction of it getting healed or not. And that work's been published. You can read more about it. We published that about 2 years ago in Nature Biomedical Engineering. And afterwards, I thought a little bit more broadly on what I'd want to explore in a non-technical domain. And I pursued a postdoctoral research fellowship with the Stanford Center for Biomedical Ethics. And this right now, I'm focusing on thinking about the policy implications of using big data, or thinking about more broadly the implications of big data in the domains of how it affects patient lives. And so what I'm going to present today is going to be focused on just the thinking exercise that we've been working on over the past year to really drive in this theme or this topic around unintended consequences. So to start off with, this work stemmed from a paper that was published as a commentary piece by a few faculty members at Stanford that were concerned around the use of using AI in the scope of drug discovery. And when it is allowed to run wild, so to speak, the thought exercise of what one can do in using a big data and big data analytics to potentially find harmful or dangerous drugs or things that can harm humanity. And these scientists wrote a commentary piece around the concern for not having a structured kind of framework to think through these types of questions. And so their whole takeaway was that the perils of machine learning and designing new chemicals and materials, and they really didn't know how to overcome this dual use problem. While the primary emphasis, and I'll be referring to the term dual use throughout my talk, the primary kind of terminology around dual use is you have a primary function where you are having your algorithm or you're clustering your data to have a primary output, but the unintended secondary output of what you might not have it as your primary focus is a point of concern in which these scientists brought up. And in the case of this paper, they were bringing up it as something of having dual use problems in the scope of chemical engineering. And they brought up this concern of not having frameworks for mitigating these. And so that paper led to this thought exercise of what else or what other fields aside from the areas of chemical engineering can be an area of concern. And that led us to more broadly thinking about frameworks in biomedicine and the scope of using AI in biomedical applications. And we approached this by kind of thinking about what is this aspect of dual use of AI in research development, and scoped it from just what are those concerns or areas of concern that would lead to potentially unintended secondary effects or secondary consequences for using AI models in biomedical application. Things like tweaking existing models for bioweapon development, repurposing existing AI for more problematic purposes such as polygenic risk score calculators or employment decision-making support, tweaking and repurposing for unintended surveillance purposes, and that's just a start. And these were kind of jotted down notes of potential points of concern and where there could be problems identified for a wide range of dual use applications. And so the terminology that I am going to kind of interchangeably use today are words around dual use, reasonably foreseeable misuse, potential misuse, or forbidden knowledge. And this really ties into these different ways in which different domains and different fields speak about the flip side of the coin to what they'll be working on. In the case of people who are working in the defense industry, for example, it's more often to use dual use in the scope of weapons development, whereas potential misuse or forbidden knowledge is more on the social sciences side. So, but the key crux is the communication is the same message. We're trying to think about what happens on the other side of the coin that we might not be primarily thinking about, but what would be something that could be as a unintended second effect of work. The interesting part, and kind of when we dug deep into thinking about what is happening on the AI scope or the landscape of AI regulatory kind of interaction, was that every agency, or primarily every agency, has some sort of emphasis on doing AI-related work, where they're thinking about AI as it applies to the mission of that agency. From the NIH to BARDA to the FDA, everyone has some sort of concerted effort in their specific subdomain around AI. And across every department, there's something happening. But what was most prevalent, and when we're just kind of looking underneath the hood, was that there's no real true concerted effort cross-departmentally to understand, to capture this the thematic approach of how it is that we should be thinking about AI, and particularly the unintended consequences around applications for AI. And so we went on this journey to scope out a definition of what it is that we want to define and how we'd want to frame this definition of dual use, because as it applies, and specifically as it applies to bio-related applications. And we wanted to figure out how do we frame this framework, having a certain set of principles and having concrete policy recommendations for the use of these principles, and kind of identifying who are those key stakeholders and how do you account for accountability and some sort of reasonable approach to developing said framework. And then the aspect of having some sort of government's recommendations as something as similar to the AI version of the NSABB. By the way, if anyone has questions in the chat, feel free to drop them. So the effort here was what started with some grounding considerations. And when I say we, I will kind of frame this as this effort is about a year's worth in the making of a group of faculty, both faculty and industry participants across campus, from policy, from law, from sociology, from bioengineering, from biology, from computer science, from the ethics department, as well as from industry or folks who are working in industry roles that are aligned with having the thinking about areas of concern as it pertains to AI in the scope of biomedical application. And the consensus throughout this entire talk is the folks, everyone was who are participating was giving us feedback as a committee from which we were then taking these recommendations. And then at the end of my talk, I'll show you kind of the summary of this model framework that the committee came up with. And so some grounding considerations that we had at the launch of this effort was to understand who our audience was for these recommendations. And the focus would be to have it be researchers doing this work and institutions that they're a part of. And what we were aiming to address was thinking about what are the obligations that researchers would have to mitigate harm, and how do you make good judgments about what should be done, when, and how, to have a concept of a framework, to think more through the implications of using AI and the secondary effects of AI in biomedical applications. When we were assuming about the state of the world is that there is an aspect of needing principles, that there is a potential and likely use case for these principles, and there were unacceptable conditions in which these principles would not be applicable for. And we're thinking about mitigation strategies to consider. We were really thinking about the secondary effects outside of this primary indication. So the flip side of the coin of whatever the work that someone might be working on. And we were framing our questions around kind of thinking about what would those extremes or edge cases be, such that we can distinguish between both research and practice or application of set models. And the 5 use cases that we started with after just talking with every committee member and asking the question of thinking through what are the areas in which you consider there being high secondary risk or secondary effects or potential flip side of the coin thought considerations around using AI or the applications of AI in the biomedical space. And we came to a consensus for the starting of 5 use cases. The first is ambient intelligence, primarily in the use of hospital settings for that could be used for employee surveillance, and that can be overlapping with wearable mobile health. The second was AI for drug discovery and chemical toxicity research. The third was polygenic risk scores and their ability to be both used and abused. The fourth is inferring phenotypes from patient databases, particularly for people who are working with things like the UK Biobank and similar types of data sources. And fifth was generative models for creating digital twins or synthetic population data, and this concept of this growing area of research of folks who are working on synthetic data as a means to model the human condition. And in doing this, we identified that there was a need to frame our definition of what it is that we're talking about and whether or not it is actually quote unquote dual use. And so we came up with reframing the definition to the words unintended use. It's not just used for malicious purposes, but it's something that impacts the broader population. And in doing so, the first task was identifying the use cases. The second task that we had for the working group was to tell us in each of the use cases when it would be when the risks would be very low and one should proceed, to when the risk would be moderate and you would have some mitigation strategies, to where the risks would be too high and you should stop and not proceed. And kind of on that spectrum, identifying what would be potential mitigation strategies to think through as work is being developed. And so the consensus through that discussion was 3 types of mitigation strategies. The first is using existing mitigations in the non-computational space and potential misuse of or dual use of research of concern, similar to what's been done with the gain-of-function research work and lab protocols. A second mitigation strategy was off-the-shelf solutions from a range of ethical issues that AI raises, such as data bias measurements and preventing targeted misuse against marginalized groups. And finally, design-specific features. So these are referring to specific use cases designed to that would block potential misuse and strategies such as privacy-preserving techniques and ambient intelligence, such as face blurring. So specific applications in a specific use case that would allow for mitigation strategies to prevent misuse. And so I'm going to go through the top three of those five. From the five, we identified top three use cases in which we then framed this framing around mitigation strategies. So the first is ambient intelligence. Ambient intelligence, some of the risks associated with ambient intelligence is the having it be misused for surveillance, unauthorized data usage for broader populations, things like smart toilets. The application of the environment affects privacy and associated with disclosures and having folks who are involved knowing whether or not the benefits outweigh the risks of being monitored, and specific use cases such as for elderly care or falls. It showed promising benefits in improving patient care, and also potentially offering legal protection to those said patients. But the ramifications of that could be potentially the monitoring of the folks who are doing the elderly care, and kind of thinking through those as well. And some mitigation strategies that we came up with for ambient intelligence as it relates to thinking about the flip side of the coin was to have rigorous applications of laws and regulation, particularly as it pertains to user consent and data use, and having a required opt-in versus an opt-out, and having design-specific features for customized user control. The other aspect was thinking about the using advanced security measures such as homomorphic encryption, digital watermarking, to make it such that data was de-identified and you could not easily trace it back to the original kind of individual. And finally, evaluating the balance between surveillance and the risks and benefits, and whether or not you do need to have an aspect of ambient surveillance or not in that setting particularly, or if you can go around without having it. The second area of the top three, so the first was ambient intelligence. The second that was in the top three contenders was AI for drug and chemical discovery. The risks associated with AI for drug and chemical discovery were that there's non-computational strategies for biowarfare that are publicly accessible, but the barriers to entry are lower for AI than biowarfare applications, which are referring to the concept of, if you want to build a nuclear bomb, it's quite easy for you. It's quite hard for you to do that because of just the need of having access to the materials, whereas having access to data and an aspect of an algorithm to dissect certain data has the lower barrier to entry. And there's also potential for having that data from leakage from the scientific to social commercial spaces, more so to kind of how do you prevent research that is being done for research purposes only from being used in other spaces. And the final risk that we identified was this aspect of dual use or reverse engineering of AI technology, where you don't have clear boundaries for misuse. So you could be working with a primary emphasis on a specific technology, and you then you're not even thinking about what this boundary is between when you should stop between it being useful versus it being not useful. And the mitigation strategies that we came through is thinking about the premise behind the entire work here is that the consensus between the work is it is impossible to regulate AI as an algorithm, because inherently an algorithm is ever changing, and because of that you cannot quote unquote regulate it. And so the thought behind all this work was focus on the outputs rather than the process to which those outputs are being obtained. And that output, the emphasis on, if we're speaking in the AI for drug discovery space, focusing on potential malicious actors rather than the AI technology itself, and then more of a reactive framework to address things as they emerge, rather than balancing access to information and also transparency in the decision-making process as a mitigation strategy. And it was very clear, particularly from folks who are doing research in this space, that having universal access to AI tools is necessary in order to prevent power disparities or silos, and where folks have tools, have access, and then folks who do not, and then that would lead to kind of an aspect of oppression. And so the emphasis was on having proactive measures to have a system and where bad actors would be stopped, but everyone else who wanted to do it for research purposes would be highly encouraged. And this strategy came through the aspect of having universities take more on an active role in providing resources to think through like a component of self-regulation, or whether or not there's an urgency to develop a certain algorithm and how quickly it needs to get to the market, and having folks across disciplines work together to think through problems and having different stakeholders engage with each other on these topics. And finally, the last use case that I will focus on today is generative models for synthetic population data. So the risks associated with these, while as research, the risk was deemed low, the sharing and application of patient data has certain challenges potentially in the domain of privacy and data fabrication. And using certain AI tools raised questions around justice and equity issues, particularly if we have data that is non-representative of the entirety of the patient population to begin with, and using that as a baseline to build synthetic data might not have full representation of the patient population group that we'd be interested in studying and learning about. And so there was a risk of also a component of having personally identifiable information being able to be inferred from the synthetic data as well. Those are the risks that we came to consensus on. And our mitigation strategies that we thought through for having for those risks was to create incentives, again, to have AI researchers and social scientists to kind of think about holistic problem solving, and including communities who might not be fully represented in those data in themselves, to bring them into the table and encourage community engagement to address equity and justice issues for a more representative patient demographic, as well as in the AI research domain. And then having metrics for privacy and protecting sensitive information to have a certain safeguard from having personally identifiable information be actually be inferred from the population data. And the summary of it all kind of came through to this slide here. And so the workflow or the framework, so we started with the problem. The problem was that these research chemical engineers said there is no framework that exists for us to work through our problems. We need to think about a framework for us to help think through, if the work that we're doing, how we should approach that work. And so our process was summarized into this figure, where we have an aspect of beginning your technology development, engaging the right stakeholders, mapping out the risks and benefit landscape. If the risk was low, thinking about mitigation if we need to continue that risk. And then if the risks or there's nothing to mitigate, we implement mitigation strategies. And again, think through, if the risk is low, proceed with research. If the benefits outweigh the risks, proceed with the research. If the risks outweigh the benefits, do not proceed with the research. And kind of thinking through what would be those mitigation strategies to think about as a means to making sure that the research work that's being done is done in a way in which folks can then do upstream mitigation of downstream risks. So I'm excited to kind of get this paper has been submitted for publication, and so we're excited to kind of get this out. I'm giving you all a sample of what we'll be launching soon. So yeah, with that, I think we're roughly at the time that Peter asked me to talk about. So I'd be happy to answer any questions around some of this work that we've been working on.
All right, let's give a virtual round of applause. Great talk. I can start with a question just as people are getting warmed up. So I guess one potential comment with the framework you just presented is that industry's going to proceed even if researchers pause the looking into these. So do you really think it's a good idea for researchers to stop while these big tech companies and others will continue with these, or maybe researchers should continue, but there should be concurrent ethical reviews that occur. I don't know. What are your thoughts there?
Yeah, super good question. So one of the reasons why we had external folks participate in this framework development was because of that initial concern of, well, why does the academic field need to operate differently than a non-academic field? And another kind of comment that we received through working through this was that this framework is not intended to prevent research from happening. The goal of our work was to allow people to think through what could be potential harms that might be elicited through certain developments, and how do you think through that. But the thing that I didn't bring up as something that is now being started to think about is the incentives for people to actually do this versus it just being there as a recommendation system. As this is something we thought through, here's a framework for it, but using the framework is much harder than actually having a framework to begin with. And so like one effort that I can comment on namely is at OpenAI, and they are pretty well known for their work in the aspect of natural language processing. And they recently published a blog post around a risk assessment work that was done. I'll drop it in the chat here if folks are interested. Let me see, OpenAI. Where there was some kind of thinking about, okay, a model in itself can inherently be used or hacked to give you problematic output. So in this specific example, what they worked on was, and I'll drop it in the chat as I find it in the research work. Here we go. So this guy here. So there's so using an aspect of using LLMs as a way to aid in the biological threat creation, thinking about developing a blueprint for evaluating risk that with a large language model that can prevent someone from using or developing a biological threat. And the process here that was done was a group of researchers and participants participated in trying to jailbreak the algorithm, ChatGPT in this case, in order to identify how you could ask the questions in order for it to give you an output that might be considered high risk. And like, how do you develop a nuclear or not nuclear? How do you develop the next COVID virus or something that can be used in a malicious effort? And then thinking through, how do we prevent that from happening while also not stopping research work from proceeding? Because as I mentioned kind of in the middle of the talk, you want to not inhibit progress and development of work. And knowing in at least in my own work, the computer science field is always evolving. You have a model that was developed a year ago that is not as good as the model this year, and then the model next year is going to be better than the model from the previous year, just based on the nature of how these the cycles of algorithm development work. And so it's more of thinking about the outputs and how do you prevent certain outputs from causing harm, and then putting those safeguards in as the models are being developed. And so at least at OpenAI, that's something that they are actively thinking through and getting human in the loop development, so to speak, this new term around human in the loop development for having human trainers help with fine-tuning the models around certain aspects of risk to have better trust and safety components for preventing misuse, but also encouraging development of work.
Awesome. Thank you.
Artem, I just have a question. The flowchart that you presented reminded me of the process you go through for human research, that you have to get approvals and you have to be monitored, and that never came around from the field policing itself. It came around from really pretty extensive harms being done to people that were participating in research before the government actually came in to regulate human research. And I don't really see the difference between the harms here, because the harms can be rather substantial. And I don't really think that this division that Peter was talking about between industry and academics is a viable one, in that we can't really trust industry to self regulate themselves because profit is a driving force. So I think it's just a matter of time before you set up a structure that has pre-approvals before you go through this. And it's very similar to what you have there, but I don't think it can be done by self-policing. And the important aspect of that, I think, is the Data Safety Monitoring Board. When you have a trial go on in human subjects, you have a non-invested group that's monitoring the outputs to make sure that these fail-safes are in place. And that's part of what you showed here. But what are your thoughts on that, about self-policing versus government really stepping in and making AI development similar to human research development?
No, you bring up a really good point, and that's like after a year's worth of work and kind of working with folks on thinking through this problem, the biggest area that folks stopped on the next part was, well, how do you incentivize people to actually care about this? Like there's a component of the self-policing that you bring up, which inherently folks may use it, folks may not use it, and that's just the nature of any kind of self-thinking, self-process of an identification of risk. My sense, based on how the trajectory of the field is going, is that we need more computer scientists involved in the development of the legal policies around how to mitigate certain risks, rather than just leaving that up to folks who might not fully understand the systems that are being built. So with respect to human subjects research, that all came about from there was significant harm done. And because of that, there needed to be consensus and frameworks built around having more kind of a guided framework for human subjects research. Now, do we want to have the same happen with AI related work and say some big harm comes from using AI, and then from there a reaction framework would be developed? I feel if we go down that route, then what could happen as an unintended consequence of that is that research may be halted, and folks might say, well, we don't get this. We don't want to fully, we don't understand what you're doing, but we also want to mitigate risks. And so we say we'll encourage everything to fully stop. There is, and the right answer, and I think that the right answer is that folks who are doing the development work should work with folks who are doing the policy implementation work to help think through, how do you make sure that your research is not going to be abruptly stopped, but also doing it in a safe way, and where you can help with the development of using AI in a way that's not harming people.
I have a question. So this is about your stronger regulation of AI and biomedicine paper. So a lot of the framework changes proposed in this paper are extremely ambitious. I mean, there's changes to the FDA, to CMS, to state level governments proposed. So what do you see as kind of a realistic either priority list or path forward for what you've proposed?
Yeah, great question. So in that paper, the Science Translational Medicine paper that Peter referenced in the beginning, the emphasis there was thinking about if the use of AI tools is going to be much more broadly distributed across these different areas, and because each organization right now has a non-unified focus around thinking about the application of using AI in their different domains, then in order to like really get it to work more in unison, a lot more levers and knobs would have to be tweaked and turned. The reality is that it goes back to the incentives of how do you incentivize folks to be interested in using and thinking through, how does AI apply to the work that I'm doing, and then using that in a framework type of way. So to answer your question, there is the goal, and then there's the process towards that goal. And the computer scientists need to be involved with the people who are doing the policy development work. I've seen kind of this aspect of not fully understanding something comes to just fully rejecting it. And I don't think that we need to overregulate something, because that will not allow for the development and progress of certain things. I think that it's an aspect of making sure that the folks who are doing the development work and the model development work are communicating that more effectively with the folks who need to think through the high order consequences of safety and aspect of helping the patient populations and so forth. And so more involvement there. I know, oftentimes, even myself, when I did my PhD work, you're kind of siloed in the work that you're doing. You're focusing on the efforts that you want to get through, get your project to the final results. But then the secondary and tertiary effects of kind of how does that work apply to more broadly to patient demographics or to patients is something that you don't actually think through. But in the work that I'm doing now, I really get to see that a lot more of just being involved with communicating better to folks who are doing policy development in terms of what is an LLM, for example, the most basic thing. What is a large language model, and how does ChatGPT-4 work? So, or how does generative AI work, and to the aspect of image generation and so forth. For example, I think there was I saw a news article about a bill that was proposed in response to the recent Gen AI images of Taylor Swift, and that whole aspect of um, um, uh, images that were generated that were not kind of safe images that were generated on Twitter. It was shared actively, and so the Twitter blocked Taylor's name from being able to be searched online. And then now there's a bill that is being proposed as a reaction to that, and thinking about AI safety online, and particularly with use of a Gen AI in images. And I haven't read the bill, but I can guesstimate that the efforts there are very much like, we don't fully understand this, but we need to make sure this doesn't happen. So we're going to react to it, or we're just going to say it's not allowed in everything. And so I don't know if that's the best way to go about it, right? Versus making sure that the folks who are doing the development are not stopped from being able to proceed with their work.
I'll ask one more question. Sorry.
Sure.
Um, back to that paper. Thank you for your previous answer, by the way. That was super helpful. A lot of this, especially when you're talking about informed consent for patients and how physicians need to communicate that, seems to be directed at patient-facing uses of AI, like diagnostic AI. How, if at all, do you see the informed consent process for physician-facing AI, like LLMs that generate clinical?
Give me more context in terms of what is your background. I'm curious, are you a professor? Are you a physician? Are you a student? Help me understand that more.
I'm a computer science graduate student at
Okay.
UH.
And what kind of work do you work on?
I do medical imaging AI.
Got it. Got it. And so there's the aspect of in that paper, we really kind of focused in on the folks who are being affected by the decision-making process of decision-making support for using large language models. With physicians, I would say we didn't really drill into that in that paper, but it would be in the same domain, same scope of a domain of kind of also helping them understand the process of what's happening and how their decision would impact patients as well. But it's a good point that you bring up, because it's an aspect of like, well, is it the patient's responsibility? Is it the doctor's responsibility? Who's at fault if it goes wrong, and how do you make sure that the fault is addressed? And that's a question that I feel like is not fully answered in any domain yet, particularly in the space of AI and biomedicine. So.
Other questions? I have one more question. So what One thing that I often talk about is that in AI ethics, there's a lot of trade-offs that occur. So, for example, one is fairness and privacy, right? Where you can not share data, be more privacy preserving, but then if you're not sharing data from underrepresented groups, that's going to result in more biased models. That's one end of the spectrum. Uh, what's leaning towards privacy preservation, then you have the other end of the spectrum leaning towards more fairness, which is okay, actually get more data from everyone, but that's at the expense of privacy, but at the benefit of removing bias and increasing fairness. So how do you see these regulatory principles in that context where there's not necessarily a right answer, but maybe a dial that you could be moving in terms of what you want to, what values you want to prioritize, both of which different groups or perhaps everyone, people see both as important, and depending on the application, one might be preferred over another.
That is the $1 million question, in terms of how do you do it, right? Is this component of, well, do you skew this way or do you skew the other way in terms of the dial? And I think in what you were asking me just now, the word application in terms of the specific applications, that's where it comes into play mostly, particularly as it relates to the output of what you're trying to dissect through. So in an effort to kind of get more representation in order to have more folks involved, an aspect of community engagement is super important there, right? In terms of getting folks who are from those underrepresented groups to be involved, to having an like component of data integration that is more representative of patient populations. Then how do you also make sure you preserve that balance? It's a hard question. And I'll be honest, it's a hard question to kind of think through, and the framing around it, my mind is always around the aspect of how do you enable the person who has that data that is being shared to feel empowered about their data being used for good, and then also making sure that they understand the entirety of the process and can be involved in that decision-making process. And I do think that it's very important to include human in the loop development early on rather than later on in the kind of the development cycle, and pulling folks in. So that was one way to kind of improve that and help through that process as well. I think there's a question in the chat from Dieter. Dieter, if you want to mention it out loud, go for it. Or I can read it. Is that the question in the chat? Should privacy not always be less important than medical research? At least in medical research save lives. So is the question here, Dieter, focusing on more privacy than research, or like are you suggesting that there would be more privacy and less research done, or more research, less privacy? What are you kind of referring to here? Okay. Okay, well, I'll take a stab at his question. So kind of thinking through, should no worries. I wanted to make sure I understand where you're coming from with your question. And so should privacy not always be less important? I mean, it is super important, particularly in the framework development that we were working on. We wanted to make sure that it is important to highlight that patient safety and patient privacy is an important aspect of having data that is both representative of the patient demographics, but also it is, what is that right balance between the component of having data that is representative and data that can be used for medical research. And the consensus for the groups was that having data that using new data techniques to be able to make sure that we're preserving patient privacy and not have personal identifiable information be identified from that data, but also developing new model techniques in order to be able to better and more accurately model interactions of diseases and drugs and kind of things, and where you're needing that type of data for whatever you're developing. And So things like federated learning, things like building out synthetic data sets that are fully representative of patient demographics was that balance in which the group, particularly the folks from computer science and the engineering departments in the working group, thought would be the most practical way to really drill through this balance. But it is definitely something that is an important thing to think through, whether or not, like, what is that trade-off between having making sure that you're protecting your patients and making sure that their information is not shared versus being able to do academic research or any kind of research.
I think there again, it started off with an idealistic situation where research took precedence over privacy. And then there were just terrific harms that occurred that caused HIPAA and other laws to be put in place to make sure that people are protected from the harms, and especially denial of care, denial of insurance, were some of the big ones that came about. So I think a lot of the environment we're in is not regulatory first; it's regulatory way after. Sort of like most laws that seem really stupid are because somebody did something really stupid to cause that law to be in place. So
Exactly.
I really enjoyed your talk, and I really enjoyed discussing these and thinking about these thoughts, because there's so many parallels to non-AI, just human research, that I think the computer science community will follow a similar pathway ultimately.
Totally agree, particularly with like a lot of the frameworks that have been developed in the past for different indications were like the reaction frameworks. Something happened, we got to react, we have to fix it, and then the entire field is affected. And this notion of being involved before something bad happens and helping it be framed such that you can continue to do research, I think is something that, if as a computer scientist, I think that is important to have, because that way you don't like I'm all for innovation and all for kind of development work and research work, but it's a component of making sure that folks who are doing the policy work understand what is it that's quote unquote regulated versus what is it that can be a harm, and how do you prevent malicious bad actors from accessing certain data rather than people who are doing research who are doing it to improve the human condition in some capacity.
There's something you didn't talk about, which I think is related, and that is the potential for being able to use a secondary AI model to back solve specific data that was used to build the model, and to be able to determine if that data was legitimately obtained, or if it was obtained in a kind of a benevolent way. I think the original thought was that once that data is used to train something like a CNN, that it's difficult to trace back the source, the training data. But my understanding is that that's becoming much more possible, to where you can identify the specific data used and in the model, and that's in a sense has to do with not only data privacy but also proprietariness of data. So do you have any thoughts on that?
In terms of using a secondary algorithm to find the information of the data from the first algorithm, or what particular component?
Well, I mean, is there really any true privacy when you start getting into large models like this?
Google and Facebook know more about us than we do sometimes. So, is there really true privacy? I think in the age of, depending on how we define privacy, right? If we're defining privacy based on like not having any kind of online footprint, then nowadays it's quite hard, right? To not have that.
I was really implying more like I have a mammogram from a woman with breast cancer, and it's a particularly high has a high recurrence rate, and if that data was used in a model, and but that image was somewhere in a insurance database or something, then being able to match those images up could break the privacy and of that individual, so that she's, there may be harm involved in terms of denial of services.
Yeah, no, you bring up a super good point. That was one of the areas as we were kind of thinking through the use cases. That was one of the aspects of, can things like certain data be used to update insurance policies in order to have insurance companies use certain data in order to kind of change premiums based on more of a reaction approach versus kind of having a policy. And the short answer is it's a complicated question, because you can, like, if we do a thought exercise, what if we did find that image from that patient was used in a model? The high order question is, who's going to act on that decision? Is the insurance company going to go and use that information and actually do something with that, or like, at what point does it become, we now know that image was used, to something was acted upon that information? And that is this component of research, and where that's not fully fleshed out yet. I don't have an answer to that. I don't think anyone truly, like, how would you apply a regulatory framework for that? Would you tell insurance companies you cannot do that? I don't know if that would even be something feasible, right? And to answer your question, I think it's a really good question, to kind of needs a little bit more thinking through.
We have time for one more question.
M. Racy, I believe, has a question.
Yeah, I made sure I blocked this. I saw that there was a development in smart bandages, which is something I've talked about at length with a few other people, because it's, accessibility with Ariana is a beautiful thing, and start with bandages. That's awesome. I'm really impressed by the thought process, because we seem to overthink our approach on healthcare in AI, and instead of dealing with the simple things, we're shooting for the moon, which is fine. But accessibility bandages, this is humongous. This is stuff that everyone is going to be able to participate in. And that's what's beautiful about it, because if you get buy-in on things that we can all use, they'll start to see it. You know what I mean? Like, you have to get your foot in the door. So things like that will solve more global issues. My thought process is, if you put AI in the middle and you put all of those people around you in a big circle and find the connector, and start there, you're going to have, like, everyone will get on board. You know what I mean? Because it benefits them, it behooves them. Right now, they're going to fight you because they have no concern about that one rare disease, which is why I keep paying attention. You know what I mean? Now, that said, I am not in the healthcare, so I will not speak on anything healthcare related. I'm more on the AI side, and business side, and that's why I thought you guys could use that perspective. You know what I mean? And I'll tell you guys right now, it's the first time I talked, Hawaiian sativa is a miracle drug. I'm just gonna throw that out there, okay? Just so you know, it's not being used effectively. Now, that said, I thought I read that you created a closed loop system. My issue is not, did you create a closed loop system? Did you create a financially viable closed loop system?
So with respect to your smart bandage question, closed loop meant that we were trying to have all data decision being made on the device, rather than it being going to a cloud and then back, similar to a Waymo car that's doing self-driving and trying to do localized delivery of decision. Whether or not it's financially viable, that is the biggest question. The next part is, like, how do you make
Can't
sure?
figure it out, man. Sorry to cut you off. Like, no one can see it, dude. That's the whole thing. You know what I mean?
That's the thing, is it's the incentivization of the payers to say that this smart device will help you by having patients be less, the admission rate in the hospital would be less. You'd have less time spent in the hospital, better treatment outcomes, and that would lead to better decision support, per se, in terms of having better kind of patient facing care. So where that work is, we had a smaller version, the prototype now being developed to scale up a battery powered device to be scaled up to human production. And the idea is, there are CMS codes that you can use for the treatment that smart bandage is outputting as a way to pay for it. But the added benefit of sensors is something that you would need to prove to payers that this adds value rather than just taking gauze and wiping that out there.
Yeah, yeah. And that's like one of the biggest issues. Like, okay, so in my industry, I work with a utility company. We have a third-party provider come out and inspect our work before we hook up with it, right? We do large-scale operations, no big deal. So having someone check it first, like that would be like, it's called an AHJ. It's an authority having jurisdiction. They're not related with either person. All they do is they go down a checklist. So that's a brilliant concept. Now, the other concept would kind of be like applying for a permit with AI. The issue, and the only issue, is theft. The people developing the AI need a head start, and it's so secretive because if you're a smaller, like you guys, I've seen your videos, there's like 5 of you. It's going to take you a lot longer to develop a system than 500 of us, right? Like in Ready Player One, right? You know what I mean? Strength in numbers. So if you have to apply and you tell them I have this concept piece, there's nothing to stop someone else from beating you to it. Right? Which means that all AI will basically go to the largest stakeholder. And we all know that's Google. Right? Like, you know?
It's a hard question, right? But that is why, we need more people working on it, to kind of solve that question.
Right. So that's this. It's like you're constantly chasing your tail because it's new. It's the Wild West. Regulations will happen, but if we do it, like the man was saying, if it's all regulated government-wise, well, it's intentional stagnation and we're never going to get anywhere. And we'll still develop it in the backgrounds, and then there'll be a witch hunt on you developing AI as some sort of terrorist when you're trying to save lives. So it's just
That's just not true. I mean, there's a balance between development and speed and safety. And yes, it does slow things down, but like I said, there's reasons that things are in place the way they are because the harms can be immense, and that's just the way it's going to be in the future. I'm certain about it. You can't take the ivory tower approach that the field can regulate itself and there won't be any consequences. And the FDA backs up this type of regulation with strict laws. And so, yeah, you can say people would develop it in the background and they something very harmful, but that would be illegal and you would be held accountable.
No, I'm saying people would still be fighting for good, but they would be forced to the background. That's what I'm like, you know what I mean? Like, well, like if you have people, if you allow it to the government to like put the regulations, they're going to fight it for a very, very long time, and it's going to be intentional stagnation because they're scared of it.
Hey, sorry, I have to cut this off. Our speaker has to go, so let's give a round of applause. Great talk.
Thank you.
Yeah, thanks very much, Artem.
Appreciate you all. Thank you.
Yeah, this was a great discussion.
Yeah, happy to, and thank you for the good discussion. Appreciate you having me.
All right, thanks so much.
Okay.
Take
Bye-bye.
care. Have a nice weekend.